Hello, everybody. Good morning or good afternoon, and welcome to this Sparring Partners on Rethinking AI AIOPs. It's all about the data. And this is a Sparring Partners that it's in a series that I'm doing on AI, automation, and all the surrounding topics. And you can see, I'm going to send you a link soon to previous Sparring Partners. And this fits very, very well into this whole series, which is going to then be part of a report that is going to come out very soon. And the reason for that, it's because and the reason why I'm writing this report is to go beyond the hype and to talk about what is that we can actually do to get AI and automation off the ground. And IOPS is crucial to that. But not only that, it's really crucial in trying to understand how we can get it to work. So to go beyond the sort of the high level general sort of this is good, this is going to be a major change, but how do we actually get it to work? And this is what we're going to talk about today, is that in order to get it to work, we need to kind of go back to the basics, to data. This is kind of an old school kind of the thing that has always been there, but we've not been able to use as well as we could. And so I am very excited to have Rick Fulwiler here today to talk to me, and to all of us, to talk about how we can actually get AIOPs to help us in a concrete way. So Rick Fulwiler is the Chief Solution Architect at NETSCOUT, and he has huge amount of experience in getting all of the bits together. And so we will go and okay, before we start talking, a few housekeeping. As many of you know, because you've been already on Sparring Partners, we do not have a Q&A at the end, but we really want to hear from you. So feel free to either send us questions in the Q&A or to chat and tell us what you think through the chat. You can chat to us or to everybody in the audience as well. Don't wait until the end. The sooner you get your questions in, the more likely you are to have them answered, because we will just weave them in our discussion. And really, that's all there is. So with that, we can get started, and I would like to welcome again Rick and ask him to tell us what he's doing at NETSCOUT.
Sure, Monica, I'm more than happy. And again, thanks for having me on the program today. I'm happy to give you a little bit of in the audience, a quick intro. So as you said, I'm the Chief Solution Architect working for the CTO here at NETSCOUT, generally focusing on data curation for AI pipelining and all things 5G standalone and analytics. So I came to NETSCOUT via the acquisition of Tektronix Communications back in 2015. With my last assignment with TechComs was Vice President of EMEA Sales out of our UK office. And then I've been repatriated back to the US and joined the CTO office here at NETSCOUT. So between NETSCOUT and Tektronix Communication, I have about over 18 years of service and about over 35 years plus, I won't go into the how much plus, in the telecom and datacom sector.
No, absolutely. And that's an interesting background. And at NETSCOUT, you've been doing I mean, NETSCOUT before even AI became a thing, you've been working on analytics, getting the data. So you have a lot of relevant experience here that you're bringing into this new area. Why don't we start by sort of giving people an introduction? So we talk about AIOps. Why is it relevant? Why are we talking about that?
Well, I think it's relevant for a lot of different reasons. And I think one of the ones is that the telecommunications industry in general is a little bit of a rough patch right now. I think if you look at revenue growth and profitability, it's starting to decline. Operations costs are actually starting to rise quite substantially, especially with the rollout of 5G standalone. So the question kind of becomes, how is the operator being able to operate more efficiently, drive down cost, and look for more and more efficient revenue pathways? So I think that the CSPs in general are looking at AIOps as automation technologies, obviously, to cut cost and also to boost productivity. I think the industry needs a new competitive kind of advantage or edge, if you wish, and I believe AIOps can help tackle some of those automation challenges and also start driving some untapped data monetization revenue streams for the carriers.
And this is an area where we can learn from other sectors, industries, right? I mean, although, oftentimes we always think that telecoms are kind of so far behind everybody else, but that's not really true. We're not doing that badly, right? Or
I don't think telecom is behind per se. Obviously AIOps kind of generated out of the traditional enterprise market space, and I think it has a little bit more of maybe a leap ahead in terms of how telecom has been leveraging. And in fact, telecom in general hasn't been known to leverage artificial intelligence or anything related to that until probably the last few years. But I think now, especially with the migration to 5G standalone, the more complex the network, we have a more cloud native kind of environment, we're starting to see the telecom starting to leverage this. And as I said, for the other reasons I pointed out, obviously they're looking at new automation technologies, they're looking at new pathways for revenue. And I think this is a good way to be able to leverage that, whether you're looking at just traditional AIOps or you're looking at leveraging GenAI.
Absolutely. And I guess, whenever you talk to any operator, or at least that's my experience, and it's but we're special. We have high requirements, which is true. I mean, it's mobile networks, wireless networks, and generally networks are part of crucial infrastructures. You cannot, networks do go down occasionally, but it's really important. It's not, so to get AI in general, it just, you want to make sure, but it's also true that other industries as well have their own requirements. And so is it because we have a situation where there's so much more urgency because we need to deal with the complexity that finally we come around to do it? Or is it that the technology is finally sufficiently good that we can deploy AI in an area that is so crucial?
So great question. And I think AI in general obviously has been around for quite some time. So it's just how do you start applying it? Obviously, over the last few years, with the further generation and more curation of the large language models, especially with GenAI, we're starting to see that. But I think in general, when we think of AIOps, we generally kind of gravitate our thinking toward kind of the modern IT organization, right, which combines machine learning, big data analytics, and other AI and ML technologies to automate and kind of improve the overall IT operational efficiency. But I think in the telecom world, AIOps is not going to be just a buzzword. I think it's really going to start to be their lifeline. And I think it's going to also start empowering the carriers to really start navigating, as I said, these kind of uncharted waters to adapt to new architecture, especially as 5G standalone migrates to a completely cloud-native architecture, and also start kind of refining organizational innovation too. So I think there's going to be numerous use cases for AIOps, and GenAI can be applied, especially when you look at some of the top use cases that I've been seeing. We're looking at how do you improve overall network operations efficiency? Being able to look at it from automated RAN to core to MEC. We're looking at enhanced customer experience. We're looking at insights into customer behavior and preferences. How do we do the overall improvement of net promoter scores? Some unique things that we're seeing is being able to identify traffic patterns and anomalies. When I say traffic patterns, we're talking about like heavy users on fixed wireless access. That in itself is taking up a lot of spectrum, especially if they're not doing it in the right way. For example, if they're receiving more connections than they're generating, that could be the fact that maybe they're hosting rather than actually being a consumer of data. Being able to look at monetization use cases of data. There's lots of use cases that marketing is starting to leverage the network data for, obviously anonymizing that data. We're seeing lots of use cases with AI in terms of slicing assurance for enterprise customers too. We have a couple customers overseas that are doing roadway traffic analysis, or they're looking at traffic planning, bridges, railroads, things like that. So there's a lot of use cases, and here, probably in the last 6 to 7 months, more carriers are starting to look at data exposure via open APIs, especially when you start looking at this Karma gateway capability that's out there today too. So I think there's a lot of avenues that you could start applying AIOps and also GenAI for carriers to start looking at new pathways for revenue.
Yes, and we're going to go and talk more about the use cases later, but one thing that it's in common here is that AIOps is going to provide a sort of a general framework that you can use for different use cases, which is good because it sort of gives you a generalized way to address to add AI. But the other thing that is in common in all these use cases is the fact that you have to rely on data from the network. No matter what the use case is, that's important. That's fundamental. And maybe you can talk about it because you can say, well, obviously you have your network operator, you have all the data. What's the problem?
Exactly. In fact, in NETSCOUT, we kind of call the data the hidden gold within the network. And, obviously there needs to be kind of that mining process to see the gold, right? So when we think about AIOps, we always become so enamored in general with all the cool AI part, right? And we often, to your point, lose sight or track of the critical data that drives the AIOps engines. So, when you think about the 5G standalone network, the data is literally just that hidden gold, as I said. But it needs to be mined, and it also needs to be refined. So that same process that gold goes through, the mining the gold and refinement of the gold. So it needs to be consumable and refined for the AIOps pipeline, and that's really the critical part of this. So we think back, we're not taking just network level data for network level data's sake, right? What we're doing is that we're trying to add context and meaning to the data and its relationship to other data that's being collected. So we're not taking just packet level data for packet level data sense and throwing it into a pipeline or into a big data lake and expecting some real magical outcomes to appear, right? I mean, I think in the past, especially a few years back, we've seen that, right? People have said, hey, I'm just going to grab all the network level data, throw it into a big data lake. I'm going to throw some data scientists at it, and really cool things are going to start happening, right? Well, unfortunately, we've seen that movie so many times over and over again, and it always ends the same. We're utilizing lots of resources, both labor and hardware, without the expected results. So what we're talking about is the data needs that important refinement process that I just talked about, just like the gold does too. So it needs that context. It needs the network quality that's being provided to each subscriber. It needs kind of that who, what, when, and where, along with what network conditions are happening and what network conditions are affecting quality of service. So you need also that end-to-end view too. You need the RAN, the MEC, the core visibility. You need it all packaged together because each individual element of the network affects overall subscriber experience. Whether it's a subscriber or whether it's an IoT device or whether it's an enterprise device attached to the network, it needs that end-to-end visibility. So what we do is we look at that end-to-end, we package that all together, we curate that data, we make it a consumable for the AIOps pipeline.
Absolutely, and I guess that the question is, because of the cost of processing is going down, the capabilities are up. There is a tendency to be a little bit lazy, like well, we have all the data, let's just dump it. And in fact, that is not a question of cost, actually. I mean, eventually, yes, but the issue is that you need to find data that is relevant. So it's not that so much of the data is not accurate or whatever, it's just not relevant. And relevancy is not a trivial concept. What matters and what doesn't. So how do you find out Because so yes, you need to pick, but how do you do that?
So I think a lot of the picking, to your point of what data is relevant, is related to our 40 plus years of telecom knowledge, be able to understand. When you think about solving a problem, especially if you're trying to understand, why we're seeing VoLTE issues in the network, well, sometimes you need to bring in radio experts from the RAN. You need to bring in VoLTE engineers. Maybe you need to bring in other engineers inside the organization. So literally, there's a team of people, but those team of people have expertise and knowledge in each of their core competencies. The key to this is how do you take that core competency out of those individuals, and how do you say to yourself, what data is relevant to you to be able to solve your problem? And then extract that from the network and provide that into AIOps pipeline. And that's really the key. Is when we think about AIOps, it's a lot different sometimes than traditional service assurance. Service assurance needs a lot of data, obviously, and it also needs data for deep packet analysis, being able to look at all the relevant packets, which is fine. But sometimes there's this golden nuggets out of those packets that you need, which is relevant to solve the problems. And that's really kind of the secret sauce to be able to understand what's relevant and what data is required to be able to feed the data pipeline.
Yes, and so I guess that the relevance of the data also depends on the context, what it is that you're trying to do. So the same bit of data might be relevant in one context, but not the other. Now,
that's right.
As you mentioned before, the network is becoming more complex, more open, more vendors, virtualized, 5G, standalone. How is that changing how we get the data? I mean, the data that we need in that context.
Exactly. So, obviously, traditionally, when I say traditionally, we're going back to the fact that we had, SS7, 2G networks, 3G networks, 4G, 4G VoLTE networks, and everything was pretty much available through a packet broker or some type of physical tapping mechanism. Even looking at the data coming off of the radio access elements, you had the capability of being able to tap the data or the CTRs off of the trace port. Well, to your point, as we're migrating now to a 5G standalone type of network, and we're seeing the migration to container network functions running on K8 clusters, it obviously becomes a lot more trickier. So that tricky part had to be overcome. And NetScout's been working on this problem for quite some time, probably going back at least 3+ years. And we started working with a variety of different NEMs. In fact, we did a press release back in October of 2022 with Ericsson and one of our customers, Swisscom. And this was the first example of a true 5G standalone network, which was provided by Ericsson. And Ericsson also provided their virtual tap, and they linked their virtual tap directly to our virtual probing architecture. So that process sounds fairly easy. They provided a virtual tap and we provided a virtual probe, but it isn't all that easy. There was a lot of negotiation going back and forth, engineering to engineering kind of level conversations to where we had to ensure that the data still maintained the integrity of the initial 3GPP packets. We didn't lose anything in that process. Because when you start migrating to a more cloud native type of architecture, the plumbing becomes much, much more complicated. We have this concept of NATing, so we didn't understand IP addresses. So we had to work with Ericsson. And in fact, we actually worked jointly with Ericsson to produce this concept of peer info, which went directly into the 3GPP specifications. So there's a lot of work in that process. And along with that cycle time, we're working with other NEMs on that same process. We've also developed a plugin that goes into basically a service mesh, so an NetScout Envoy plugin that goes into that. And we're seeing the more cloud native approaches starting to pop up, and we just released the concept of eBPF, which is extended Berkeley packet filter. So it's an easier way, which is more at the kernel level, to be able to have a packet. So not only do we see the general 3GPP packets from the container network functions in a K8 cluster, but we also see any other applications that may be running in that same environment. So it's a little bit more of a cloud native way of doing it. It doesn't rely upon all the unique individual vendors' VTAPs. Unfortunately, there's not a standard on VTAP, so we had to make sure we had the negotiation and what that looks like on all the NEMs that we're working with. But I do believe the eBPF is probably going to be the go forward way. So it's been a journey. Obviously we had to break through a lot of different barriers to do this, but we think, obviously we've done that. We did that with Ericsson, we did it with other NEMs, and now we're going down the path of being a more cloud native way with the eBPF.
And I guess that would be, so on day one, you work with an individual vendor, but then eventually it will just automatically work with different vendors because you do have multi-vendor, every operator has his own vendors, they're multi-vendors. And so, and I guess that's where you can add value because you can sort of have a solution that works across vendors without having to start all over again from beginning.
Right. In fact, that's actually a very great point. So obviously, sometimes there's a little bit of nervousness from the from the NEMs to be able to turn on that capability. However, if they are nervous, obviously we could still rely upon the virtual taps that they're providing. We came up with kind of a universal packet converter, if you wish. Because as I said, each individual NEM does their VTAP a little bit differently. So Ericsson may do it differently than Mavenir may do it differently, Nokia, and so on and so forth. So you're right. There's very few single NEM 5G standalone networks out there. There are some examples of it, but there are very few of them. So what we've done is we've come up with a kind of a generic 5G packet broker. So we can take all the different VTAP versions and we can run them through this kind of converter, if you wish, and then send it directly to our probe. So it allows us to have that multi-vendor approach at the same time, producing a common 3GP packet kind of on the output of that.
Absolutely. I just saw that there is a question from Aaron for you. I'm going to read it to you. It's pretty long. So anyway, so Rick, do you expect there is a need for a standardized telecom wireless data framework to help better align the data consumption or productivity in processing the data? As we have so many different vendors and they might have different types of data with proprietary data definitions, such as KPI data that are differently defined among vendors. And would there be a body working on this above all operators, as one operator's data is not enough? Maybe a joint force of many operators willing to contribute to the data and get the benefit from it, and to generate something like a telecom GPT, which is, I guess,
right. Yeah. So there's a lot of different ways to kind of go with that question. So I think the first part of that is that when we think about standardized telecom data, I mean, obviously there is standardized telecom data. There's a 3GPP spec, right? So every vendor, all the way back to 2G and SS7, followed some specification that was produced, right? So you have SS7 specifications, you have 3GP packet specifications, and that's the good part about it. So that allows us basically to tap the 2G, 3G, 4G network directly off of a packet broker and know that we're going to get 3GPP packets. So that's definitely going to be there, and that specification is definitely out there. Now, obviously, the NEMs could produce extensions to that. For example, they have proprietary extensions, and sometimes you have to maybe be able to support those proprietary extensions, but they're fairly rare, and they're done more for particular carriers for certain additional features that they're paying for. Saying that, I think where the non-standard part comes in, is that when we migrated to more of a cloud-native architecture, it allowed unique things to take place in terms of how those packets are going to be transported and acquired in that cloud-native architecture to be fed to a external probing architecture. And that's where that non-standard process comes through. I think to the gentleman's point, or to the individual's point, I think having a standard on a virtual tap obviously would be great. Having one standard says we need the data in a certain amount of time frame. The header of the information should be here, and then the 3GP packet is here. How that's provided and how that's consumed, there definitely should be a standard around that. No doubt about that. However, we believe that maybe eBPF may be a way to solve that. It is a way kind of getting around some of the unique nuances that's being provided by the different versions of virtual taps, but it is a great question. I think related to the KPIs, generally there are specifications, and 3GPP also does a great job of being able to classify the KPIs quite well. One of the things that we found is that some of the carriers actually want to modify that. For example, maybe they want to modify the equation that calculates steer for VoLTE. So one of the things that we did is we said, hey, we're going to provide that calculation for you in one of our KPIs, but if you want to go in and play with it and create your own version, then we made it fairly adaptable for our customers. So, but I think if we dig into the 3GPP specs, I think that's going to help out quite a bit. The tangential part of that question is, it kind of goes back to that telecom knowledge. What there isn't is there isn't really a playbook out there that says, based upon all this packet data, how do I know what's important and what's to look at? And that is true. There isn't that kind of playbook out there that says, I need this from the RAN, I need this from the core, and I need this from the MEC, and then I need to assemble that. That's basically years and years of experience you have to then kind of be able to curate and put into those playbooks.
Absolutely. And I guess that, standardization, I think, as you said, standardization provides the kind of fundamental for the basis, and then you can build on it. And then because, KPIs are, well, you have some basic ones, but you want to have more KPI, more metrics, whichever you want to call them. Now, let's sort of go back a little bit to AIOps and the how you curate data. How do you get there? What are the best practices? What is that you advise operators to do?
Sure. So if you don't mind, Monica, let's bring up one of those graphics, that first graphic, and let me kind of walk you through. I think hopefully this graphic will help kind of articulate some of those questions for you. So looking at the graphic, if we kind of start from the left side of the graphic and work our way through. So obviously we're looking at packet level data. And from our perspective, it could be 2G, 3G, 4G, 5G standalone. It could be coming from the edge. It could be coming from the MEC. We could be doing this in a fixed environment. It could be, a cable environment. It really doesn't differentiate from us. We're looking at literally packet level information. The issue that with packet level information, to my previous point, is it's very, very high volume. So it's raw packet data at extremely high volumes. We're looking at gigabytes and gigabytes of traffic, especially as we look at it from a user plane perspective. So one of the things we did is that we built these sensors out there to be able to process the data. And as we process the data, we're curating that data specifically for AIOps type of pipelining. So it's a little bit different than traditional service assurance, because we're not providing just every little bit of information, but we're providing the right information for the right use case. So it goes through that curation process. Thus, it reduces the volumetric part of the data. And then we're going through kind of a filtering process of filtering the right data and streaming the data to maybe different input filters for the ops engine. The ops engine may be running different types of use cases, so it may need different data for those use cases. So we can actually stream the data through Kafka-based topics or other mechanisms to be able to stream the data to the ops engine. So when we think about this, or we're speaking of kind of the curated data, or the curated aggregation and correlation, we can also kind of provide some embedded knowledge with a data set. So rather than just providing pure packet level data from an interface, I want the data provided with some context, as I said before. So some of the pre-work can be done before hitting the AIOps engine. And this is kind of the AIOps pipelining process we talked about. So it can look for specific outliers. It can also look for anomalies from, say, the interfaces. And it can do things such as looking at RTP media, such as when we have call gaps, and that may be happening in a voice over new radio call or even a VoLTE call. It can kind of pre-analyze where the gaps are. Are the gaps happening in the middle of the call, at the end of the call, beginning of the call, what's the durations of the gaps? Are the gaps happening on the uplink? They happen in the downlink? Let's do some cause code analysis, so on and so forth. So all that meaningful data is something different, and it's indicating different places of where to look for the root issue. Is it on, say, the IMS signaling side of the house? Is it a packet gateway issue? Is it a handset firmware issue? Is it a RAN coverage issue? Am I having ping pong handovers between G node Bs back and forth? So all this kind of pre-analysis can be packaged up as kind of an intelligent outcome and sent to the AIOps engine for processing with the other data sets. So I think that the key thing kind of keeping in mind here is that the AIOps algorithms really thrive on well-curated data. This allows them to generate more precise insights, rather than leading to kind of anomaly detection for anomaly detection purposes, right? So that's the key thing, is that the more lean the data is, the more precise the information is, the better the classification, detection, and prediction the AIOps engine can perform.
Now, we have the AI sensors here, which is kind of a new kid on the block here. They seem to have or they might have two different functions. They can tell you what the network is doing, so help you with the real-time data, but also they can help you with forecasting, because, well, you get the real-time data so that by putting it together with, I guess, with historical data, to predict what's going to happen. Is that right? Or
not exactly. Obviously, the AI sensors is providing the data right through the AIOps pipeline. The prediction, the analysis, the anomaly detections, things like that are still being provided by the AIOps environment, whoever provides that AIOps environment. And obviously, that's not an area that NETSCOUT is going after. There's lots of large companies that do that. But if we take a step back and we look at the AIOps kind of sensor, it's really truly a highly scalable and a programmable software component that runs on COTS hardware if you want, or it can run obviously in a virtual environment. So it supports the similar concept of packet level data processing, but it's tailored specifically to feed user-defined data sets to an AIOps pipeline, rather than using the data for service assurance use cases, I said before, which generates lots of detailed level data, which is perfectly fine, and obviously down to the packet. This data is more refined. This data is actually driven by specific use cases that are being built inside the AIOps pipeline. This is why when we look at the drawing, we actually have a feedback loop from the filtering and analytics that we're doing in kind of that streamer mode before, as the data is being curated and sent into the AIOps environment or the engine itself. We can actually then reprogram the sensors and say, hey, this data looks great, but can you also send me this? Or by the way, I don't need this, send me something else. So we have that constant capability to be able to kind of refine what we're looking for out of the network through these sensors. So again, it's not taking just every possible data set I can possibly send. I'm taking the right level data for the use cases. So we even can have a feedback loop back and from the AIOps engine. So we have a REST-based interface that allows the AIOps engine, again, whoever may provide that, back into kind of our streaming interface. And our streaming interface can then reprogram the sensors to provide which data they may need for those use cases. And it could be lots of use cases. So the streamer could be supporting hundreds of different types of use cases from the AIOps engine, but the engine is actually asking for that curated data to drive it more efficiently. And when I say it drive it more efficiently, I mean, we're talking literally down to 1 minute granularity of data that can actually drive through that engine. And these AIOps engines then can produce results very, very quickly. So it's not long-term types of trending. It's actually being able to do fairly sophisticated prediction analysis and fairly quickly. So being able to drive what may take, say 20, 30, 40 minutes down to maybe 15, 10 minutes based upon how fast the data can hit the engine and how fast the engine can process it.
Where do you put the AI sensors? So because you don't have too many or too few, I mean, so where does it make sense to have them? Because here they're all stuck in the same place, but I imagine you have that's not really in the physical network. Where is it?
So right, and great question. So the sensors are placed at the standard 3GPP tapping point. So if you look at, say, a 5G network N1, N2, the user plane interfaces, obviously user plane direct traffic is extremely important along with the control plane. So you'd be able to monitor user plane traffic by tapping N3 along with the control plane traffic, which would be the N4 traffic, and then you'd also be able to tap the control plane traffic off the SBI. And this goes back to the conversation we had before about being able to have that virtual tapping or VPF to be able to tap the 5G SA SBI bus with the control plane traffic. So it's a standard kind of 3G PP tapping points you normally would have in a network, and same thing would also be relevant for a 4G network too. So it's the same similar types of tapping points. But these sensors are much smaller scale. It's traditionally only software, and the software again is monitoring data, but it's monitoring the packet level data for very specific things that's being asked for by the use case.
Absolutely. What is the best case that illustrates this whole framework? Okay.
Right. So I think one of the use cases that's interesting, and in fact, if you don't mind going to the second graphic, that can maybe be of interest here. So the unique thing about this second graphic is that as you kind of walk through what we've seen in the 3GPP specifications, especially as this concept of NWDAF migrated as it was introduced in release 15, then in the 3GPP spec release 17, then NWDAF has been kind of deconstructed into 5 separate, what we call kind of sub-functions, right? So since this original design was getting data directly from each 5G network function via queries, it was placing additional strain on the network functions to kind of service these queries. So the approach on this slide is leveraging AIOps to fulfill those use cases, and obviously even beyond the normalized NWDF use cases, but while feeding this curated data via the AIOps pipeline. So the interesting thing about this is that this kind of architecture we're talking about here can provide the exact same level of use cases that the NWDF was spec'd out to have, but it doesn't provide for this kind of more monolithic type of architecture it needed to be able to support that. And it's not directly querying the network functions any longer. So we're not placing any resource strain on the 5G network components. And we don't have that overall complex architecture to be able to support that. So the other thing that we provide when we think about this kind of concept is we're also providing kind of a holistic view. We're providing the radio access view along with, the radio access view provides all the radio parameters of what's going on a per subscriber basis. We're providing what's taking place and the visibility of the applications that might be running in the Mac, and obviously everything that's supporting that from a core network perspective. So all the user plane traffic along with the control plane traffic being monitored in the core. So again, we have that holistic view now on all this data is being fed with the right level of information to the AIOps engine. So it can support all the traditional types of NWDF use cases, and it's a much more pliable architecture, which is now under the service provider's kind of command and control. So it's no longer kind of the off-the-shelf black box, if you wish, but rather utilizing a carrier AIOps as kind of the brain, running the use cases that are more business relevant to the carriers. This allows a carrier to decide which use cases it needs to run for its particular business, and rather than just going down a list of 3GPP use cases and saying, hey, I checked the box, but is it really relevant to the business? And I think that's the key part here. So this allows the carrier to have still tight control over the 5G SA network, while also providing a platform to migrate to an automated control as they see best. So really it starts setting up kind of a nice crawl, walk, run strategy for them. So kind of this allows the carrier to go through that adoption period, learning how to leverage kind of the derived statistical network resource usage data, along with the how the AIOps kind of calculates and improves overall service efficiency for the 5G network. So this adoption period can have multiple different phases, for example. So it kind of allows the carrier to tune the AI algorithms within the AIOps engine to fit their business use cases and their business parameters. So it gives them kind of a level of comfortability, as I said before, kind of having an automated network configurations performed based upon dynamic network or service conditions. They can kind of work their way into this. So initially, they can start with, say, the radio access part of the network, and where the AIOps engine can drive maybe dynamic radio topology, power control settings, and say multi-millimeter wavelength. It can look for interference. It can look for migration or mitigation techniques. We can look for, say, energy efficiency improvements. We can even look for 5G SLA slice violations, and then provide command control back to the orchestrations for mitigation. So from there, the carrier can also start introducing even more use cases, and they can bring in dynamic resource allocation to the core, so on and so forth. So the key aspect of this is that this provides a carrier really with the highest resolution of data through the AIOps pipeline, which is really derived before, as I said, directly off of 5G SA network packets. So it gives them this platform by leveraging the AIOps engine for more flexible use cases. So they can harness the smart data, and they can also then drive the NWDAF use cases and also build upon that for other use cases for monetization and so on and so forth. So it gives them kind of this universal platform, if you wish. But again, everything being fed off the 3GPP packet level data off the network.
So what this seems to suggest, this is kind of like, you see the NWDAF, the sort of the basic. So like, that's how you get started. That's how you learn, because I guess when you think about AIOps is that you have to learn. It's not, you can't just do it. You just need to go through a learning process, get the right data, but also gradually improve. So do you see this as the sort of like the first step, and then you spin out into other, or is it?
Right. So I think obviously the NWDAF is just one example. It may be a little bit more of a broader example, because it also checks some boxes. Not only solving the use cases that's been brought to the 3GPP environment for NWDF's sake, but also this particular example solves the use case of not have to query the container network function. So it puts less stress on the network itself by leveraging the packet level data for the same basic use cases. However, I think everything needs to be relevant to the business. So I don't want to just throw AIOps out there if I don't have business relevant use cases. And this is really the key. I think it goes back to the introduction that we talked about. What are the business drivers? How can I secure my network? How can I make my customers happy that they're using the network? How can I improve NPS? How can I look for other revenue opportunities by leveraging AIOps? I think that's the key thing. So when you think about how do I use it, the question is that, how can we make the network more efficient? How can we leverage it for automation? And how can we leverage AIOps for revenue generation? If you kind of think in those kind of pathways, then you can start building use cases behind that. Then as you build those use cases, you'll now start coming up with what data is going to drive that. Then you can program the AIOps sensor to drive that data through your pipeline.
Now, this is really an important point in terms of, it's all good because we all love the technology. So we like to have it implemented, but the question is that, does it make sense? Does it deliver the value that you're looking for? So I have sort of a two-side question: is what is that operators look in terms of value? What is that they need, and what is that you can help with? So there's two things: is that what is that you want, and what is that you can realistically get?
Right. Well, so I think it goes back to those multiple different pathways we were talking about. So I think there's multiple different ways to be able to to measure whether or not that I'm delivering value back to the business. So, for example, am I improving NPS? Is the net promoter score rather, is it increasing? Am I able to identify network patterns and anomalies faster? Is my mean time to repair dropping on average by each individual reported incident? And I think this is real important, because trust me, the VPs of either network operations or other VPs inside the organization look at these KPIs. In fact, a lot of them are actually bonus based upon how these KPIs are starting to trend down. If I'm able to solve problems faster, if I'm able to find root cause faster, those KPIs are dropping, VPs get their bonus. And if we look at new monetization use cases, all these new monetization use cases starting to pay off. Are they generating revenue for the business? So I think there's a lot of ways to be able to tag certain types of metrics and certain types of measurements to determine whether or not that these use cases are driving value back into the business.
Absolutely. So there is a lot of ways to look at it. How is it? is it easy to quantify it? And how do we go about it? I mean, to quantify the benefits.
Right. Well, I think that again, I think that the be able to quantify it, I think it goes back to those measurements. Obviously, if we're coming up with very sophisticated measurements to determine if we're generating revenue back to the business, obviously that can be quantified, can be measured and quantified. If my KPIs are trending down, and obviously, we're measuring those KPIs. We're looking at what is the mean time to repair, as an incident is reported. So I think there's lots of ways that are built into the current measurement and monitoring systems today, whether or not the carrier is going in the right direction. Obviously, churn is another way to be able to look at. Is churn starting to go down? So I think there's definitely different ways of having the ability to measure each of those use cases.
What about new services, getting more revenues? So more revenues for new services. Is that, how much of a scope for that is there, I think?
So I think there's definitely, so obviously the carriers are always looking for different adjacencies to go after, right? And as I said before, some adjacencies of them outside of, say, churn or looking at NPS or mean time to repair, they're always looking for other adjacencies which are related for data monetization. I think there's lots of adjacencies in that area. New marketing use cases. What are my subscribers doing? How can I market certain types of offerings to my subscribers? Can I have open APIs and partnerships with, say, other vendors? Can I say that I want to provide maybe the ability to have, a higher quality of video in a certain venue, and I partner with some other, manufacturer that can actually provide that particular video for me. So I think the carriers are always looking for other avenues and other areas and other adjacencies of how they can leverage the network level data, definitely. And then they have to. And as I said before, I think this is one of their quote prime directives right now. It's getting very complicated. They put a lot of investment into the spectrum for 5G. They put a lot of investment into the 5G packet core. Slicing starting to come out, so they will see potentially some return on investment on that. But they're always looking for new adjacencies where they can start leveraging the 5G network data or even the 4G network data for that sake, and how they can do other partnerships to drive their business outside of kind of their core competency.
Okay, we have another question on GenAI, which is obviously a topic that elicits a lot of a lot of questions usually. So the question is as follows: NETSCOUT is heavily utilizing the data coming from the network to do the data mining. And now, what about the GenAI perspective? Is GenAI is about generating the data. Would NETSCOUT look for any approach based on GenAI? Is there any use case from your point of view to use GenAI applied to the RAN? And do you see any new trend for operators to seek AI solutions using GenAI? That's like it's a very wide question, but let's get started on that.
Sure. Yeah. I think that's actually a really great question. So of course, I mean, I think GenAI definitely has a place. So there's no doubt about that. And I think there's many examples we've seen probably in the last few plus months of press releases where carriers are actually putting down serious sums of money with companies that are delivering large language models for GenAI. And some of these, some of these carrier customers are targeting kind of customer experience use cases, which is fine. I mean, but that's kind of a broad level statement. So it depends upon, where they're going to start leveraging this for customer experience. Obviously this could be in call centers. It could be, first line, second line support in terms of customers. But I think that there's definitely use cases around that. Definitely, I believe that large language models are going to have its place, but the key to this is going back to this concept of how do we train, and how do the large language models learn from incident knowledge, right? So there's always constantly this feedback loop, right? And they still need, as I said before, they still need the curated data that kind of drives this overall environment. In fact, if you take the converse of this and you flip it over to what's happening on the enterprise side of the house, you kind of have these teams. They're called site reliability engineering teams, right? And they have this concept called runbooks. And runbook says that when I see these kinds of problems, based upon X number of years of knowledge, I do the following different types of things. So it's a little bit more sophisticated than flowcharts, but it kind of has that same similar concept. So you see a lot of these SRE teams starting to take these run books and inject them and train large language models to go off and solve these problems or look for these anomalies and these issues much more faster. It's the same kind of concept that I think we're seeing also in the carrier space too. It's a little bit of a different type of team concept because now we're dealing with multiple different teams. We're dealing with a lot of different types of expertise, as I said before, whether it's radio access side, or whether it's RAN or other parts of the network. But it has the same kind of concept. One of the things that we did with at NETSCOUT is we kind of created these kind of similar concepts of run books. We call them playbooks. So it allowed us to be able to train some AI algorithms to what to go off and look for, what data was relevant to solve these different types of problems. So I think back to the question, yes, definitely large language models that drive AIOps platforms is going to have its place. Being able to do that in a RAN environment, as it was being asked, yes, definitely for maybe self-organizing networks, especially as you get into the decomposed Open RAN environment with the RIC controller and so on and so forth. There's lots of opportunities to kind of plug into that data and be able to do multiple different things that's taking place on the radio access side, especially looking at beamforming and waveforming capabilities, being able to direct it based upon where the customers are. So I think there's a lot of applicability in that space too, no doubt about it on the RAN side.
But at the same time, isn't it that the rest of AI, the non-Gen AI part of it, might be more suitable because in a large language model, it's based on language, and our data in telecoms is actually not language. So maybe you want to have something that is a little bit more specific, that it's kind of also smaller, that might be more applicable, more relevant to what the kind of things we have to deal with.
Exactly. I think it's a great idea because you've hit on exactly why when you look at it from an enterprise perspective, they're kind of taking this concept, as I said before, these run books, and they're now taking these run books and trying to put them into kind of a large language model that's applicable to be able to train kind of the Gen AIOps environment. So I think we're starting to see that a little bit more. As I said, we're building the kind of these playbook concepts ourselves, which it could have some applicability to start training some LLM models, definitely. But you're right. I mean, you're taking packet level information, you're pulling key nuggets out of that packet level information, but you need to know what to do with it, right? And that's the key kind of secret sauce. You need to have that knowledge. You need to have the telecom level experience to understand what's important, what's not important. And that's really the key that brings this all together. So obviously the data is golden, but having an additional knowledge on top of that is such critical too.
Now, let me ask you sort of like go back to the beginning and, back to AIOps. Why do you decide to go down that path? What kind of need you hear from your customers or internal? What made you decide to go that route?
Right. So I think, in general, NETSCOUT's kind of taking more of a strategic focus on being kind of an AI data provider and streamer, streaming the data, obviously, providing the data, curating the data, and streaming the data to the AIOps engine. And, we really believe that our data is the best in the industry, and it's essential for AIOps environment. It has to have basically extremely good, high quality or high fidelity data. So, we provide this high quality, accurate, and timely data. And another part of this is how quickly can we provide the data to the AIOps engine. So, it goes back to kind of the original saying, it's garbage in, garbage out, right? So you have to have this high fidelity data to be able to deliver really high quality output. So, at NETSCOUT, we believe that combining kind of the NETSCOUT level data with, the complementary network application and subscriber data provides really a greater quality of data to the AIOps environment. So rather than just kind of moving data around into the pipeline like other solutions in the ecosystem, we actually are now providing curated, targeted data feeds from kind of deep packet inspection at source. So we're delivering these metrics and this data into more of a real-time environment. So this eliminates kind of that data bloat environment. This is one of the things that some of our customers said is we don't want to take all the data. We want to take very specific data, and we need this specific data being able to be curated so it can drive the AIOps engine much more efficiently. And the AIOps engine needs to make decisions in almost near real time once it receives that data. So it can't be sifting through terabytes of data. It has to have well-curated data. At the same time, the customers were saying, we don't want to impede what's going on in the service assurance environment too. We don't want the fact that we have business critical applications that are driving this AIOps environment for monetization, for other things that we're coming up with, and be impeded by the fact that we may have a network outage over here, and people are using the service assurance troubleshooting system. They're doing deep packet, deep dives into packet level data. They're pulling tons of telemetry off the probes. We have lots and lots of people, maybe even potentially hundreds of people looking at this data. We may have to call in the NEMs. So what we want to do is we don't want to compete for that same level data. We want to have a clean data stream and specifically curated for these specific use cases. So that's one of the reasons why we came up with this. And it really was from the conversation with multiple different customers where we thought, yeah, you're right. You need that level of visibility. You need that clean level of data to drive these new initiatives for you.
Now, since you mentioned real time, I always ask this question. What do you mean by real time? Because again, depending on the use case, what is real time is different. Could be milliseconds, could be minutes, could be hours. How do you go about that?
So right. So it's a great question. So in general, the real timeness is down to 1 minute data. Getting data faster than that, it depends upon the use cases. Obviously, maybe if you're doing this for security type of reasons, you may want the data a little bit faster. But if you're doing it for data monetization, if you're doing it for looking at anomalies that are taking place in the network, most of the customers are coming back saying, if you can provide 1 minute level data, that's perfectly fine for us.
So yeah, and I guess it then depends on the use case might be different, but that's kind of like a good
exactly.
Now in terms of adoption, you hear you hear some of the surveys and it seems like everybody's already doing AI, AIOps, and it's like, not really. I mean, they're just starting to and adopting it. Let's just talk about, sort of to be realistic, what is that you see or you hear from operators being the challenges there? What is that? They say, yeah, it's good, but what are the concerns here that you see? That you hear
yeah. So I think Monica, early on in the opening, the carriers need a pathway to start reducing cost and increasing revenue. And from the recent press releases, the carriers are actually investing pretty heavily in AIOps and GenAI. So that's definitely taking place. I mean, there's no doubt about that. I think the good part about that is that a lot of them that are doing this are also customers at NETSCOUT. So we feel pretty good about that. And they definitely say, hey, we need this curated data. We have to have this curated data. We're putting so much money and so much investment in AIOps and so much investment in this GenAI technology. The data is so important to drive these machines. And that's definitely paying off for us. And I think it's definitely paying off for our customers. So obviously, this is this concept of AI sensors and what we're doing with the streaming capability and feeding the AIOps engine. It's kind of a new offering for us. But the good thing is that we're seeing really good early adoption. So it is starting to take off. There's no doubt about that. And as I said, there's multiple press releases. There was one that came out from Swisscom with NVIDIA investing over $100 million in GenAI. So you can see some serious money going after this sector.
Absolutely, but at the same time, like reliability, like, well, obviously people talk about hallucinations in GenAI, but in general, reliability is an issue because you don't have the same granularity of control, because obviously you have a model that you want to automate. Is that an issue? Or I guess that what you're doing is basically addressing a lot of those potential, well, not potential, a lot of concerns of reliability because you work so much on the data that it's fed, so that you avoid the garbage in, garbage out problem from
Exactly.
happening. Is that the way you see it?
Yeah. So that's exactly right. Obviously, the use cases that are being generated, it's not really NetScout use cases. It's really customer-driven use cases. So, we work together, and it's a collaborative kind of partnership between a lot of our customers. They're saying, this is the use case. What do you think about this level of data? We can say, yeah, but have you thought about maybe this data too? So one of the things that we always want to make sure is we have that level of collaboration between ourselves and our customers, and say that, we want you to be successful. We can tell you what data we can deliver to you. We can even maybe do some pre-processing, as I said before, to make the engine even more efficient as we go through that pipeline. So rather than producing just data for data's sense, if we can produce that data with some additional context, or being able to do some pre-processing related to anomaly detection, or be able to put in other additional metrics that may be important for those use cases, we can provide that. So this is why I think that bi-directional communication and partnership with our customers on those use cases is so important, so they could get a better end result.
Yes, we're almost at the top of the hour, so let me ask you a final question here.
Okay.
How do you see it, this whole thing developing over the next few years? As we said, we're just at the beginning. How should we think about adoption?
So as I said, this is a new offering for us, and the early signs is we're having great conversations, and we're having some customers that are actually starting to leverage this technology, and so we're very hopeful. We're very hopeful this is going to become commonplace over the next few years. And I think why we believe this is because we truly believe, the title of the seminar, it truly is all about the data.
Absolutely. And I think, there is really an important thing that no matter whatever the new technology is, you have to have a good foundation. If you don't have a good network, this is not going to solve any problem. It's just, you need to start it in the right place. Well, Rick, thank you so much for sharing your thoughts with us today. It was a great conversation.
I appreciate it. Thank you.
So thank you all for participating, and let me see here. So we're going to have this conversation available in a few days. Will be soon available, and we'll have more sparring partners. And again, look at the website. And thank you all for joining us, and we'll see you to the next one.
Thank you.
All right. Thanks, Rick.